So we're going to get into our lesson today, and you're not going to hear me talk much today because you're going to be doing all the work here. So today is a lab. We're doing section 1.1.2 today. Let's go ahead and put today's date on here. This is the 5th. And we'll have a look at our learning targets and make sure we understand what we're going to try and walk out of here with today. So today, the big thing that I need you to be able to do is right here. I'm going to put a star next to this and a box around it. A lot of what we're going to do in this class is translating between different representations of something. So a representation could be an explanation, like a couple sentences. Like, I'm driving to my sister's house 100 miles away. That's a situation. We would call that a situation. We can also represent situations using a table or a graph or an equation. And there's different types of relationships that we're going to be looking at, but that you're going to keep hearing those same four things come up again and again: situation, table, graph, and equation. So by the end of this first unit, I want you guys to be comfortable translating between situation, table, and table and a graph. So what we're going to do today is I'm going to give you a description of a real-world situation. You're going to work with a team. So I'll be putting you in teams in here in a little bit. You're going to be turning that description into a table, and then you'll turn that table into a graph. So right now I'm going to give you some specific instructions and some hints, and then I'm going to stick you into teams. I'm going to show you where the materials are, and I'm going to get you started. Okay? So could you guys go ahead and turn in your packet to the 1.1.2. It says, how does it grow? Okay. So there are three labs A, B, and C. And the materials are over there. I'll get you guys started in a minute. We're going to have to kind of share as one group finishes A. They're going to trade with somebody else for B, and likewise with C. But I want to give you some tips before we get started. Some of these tips aren't going to make much sense until you actually read the situation. So lab A has to do with hot tub design. We're going to be designing the floor of a hot tub out of some tiles. My big hint for you as you're doing this one is to look for a pattern. As you start building this table, see if you can find a pattern. You're going to probably have to think through the first few of these and do a little bit of math to come up with them. Or actually, I'm going to have some tiles that you can actually physically arrange. But once you get to the number 3 or number 4, I bet you're going to see some kind of pattern here. So my hint is look for a pattern. If you'd like to write that down just to remind yourself. If you find a pattern, you can use that pattern to fill out the rest of your table. While we are here, I just want to make sure we're okay with graphing points. Do you guys feel good about graphing points? If you have an X and a Y coordinate, do you know how to put that onto a graph? Could I get everybody to put a little X and a little Y above this table? When we make tables, we'll do them alphabetically. Usually it'll be X and then Y. And the X and the Y correspond to the X and the Y axes. They're actually labeled on this graph. So that one of the points, I already gave it to you, is 1, 36. Can you go ahead and graph that point for me on your graph? If you're feeling confident. If you're not, then look up here and I'll show you how to graph that one. So 1 is in the X, so I'm going to go on my X-axis over to 1. Ooh, this is tricky because this would be 2. So 1's actually kind of halfway in between. And then I need to go up to 36. So 1, 36. My first point would be right there, about halfway in between there. Any questions about graphing points? It's going to be an important skill for us today. All right. Lab B. My hint for you on Lab B is use the beans. When you get this lab, you're going to get a tray full of beans, and those beans are going to be used to represent people. I don't know, I picked beans because I had a whole bunch of beans sitting around. We could have used anything. Lab B is going to be about local crisis, a health crisis where people are sick, and each day some people get some more people sick, and over time more and more people become sick. Okay, I will tell you that a lot of people look at this and they think they know how the table is going to go without actually counting out the beans, and a lot of times they end up being incorrect and having to go back and redo their table. Feel free to ask me about your table for Lab B before you make your graph. Call me over to your group if you'd like me to check your table before you make your graph. This is the one that people tend to make the most mistakes on. Okay? All right, flip the page over. Let's look at Lab C. Sign on the dotted line. All right, this one's an interesting one because you're going to be collecting the data from your teammates. I'm going to kind of explain this one because it's a little bit more complicated. What's going to happen is one person's going to be the signer. They're going to get a piece of scratch paper, something that maybe already has some writing on it, and they're going to sign their name. Okay? And they're going to sign their name. The first time around, they're going to sign their name one time. And someone else is going to time how long it takes them to do that. So one signature is going to take however many seconds. Okay? I'll tell you how to time it here in a second. And then you're going to come back and you're going to sign your name 2 times. So we're done with that one. Now I'm going to do 2 times. And someone's going to time that. And we're going to put that time here. And then you're going to have to come back and sign 3 times. And we'll time that, and you'll put that number here. Does that make sense? The person who is the signer needs to be the signer for all of these, and you're going to get a little tired, okay? Because you're going to end up signing your name a lot of times. However, we do not need to do all of these. I'm going to ask you to scratch out a couple of these rows. So I'll have you do 1, 2, 3, 4, 6, 8, and 10. We don't need to do those ones in between. We'll be able to get an idea what the shape of the graph is from that. By the way, how many seconds does it take for you to sign your name 0 times? How many seconds does it take for you to sign your name 0 times? 0 seconds. All right, so when you do this, one person's going to be the signer, one person's going to be the timer, and then maybe the 3rd or 4th person can record, and then everybody else can copy their table down afterwards. Does that make sense? Okay, and then so the only note I need you to take here is where are you going to get your stopwatch? In the past, I have allowed one student in each group to use a phone because you have a stopwatch on your phone, but we can't do that this year because we have a firm rule that we're not having phones out for any reason in the classroom. So, luckily, you guys have your laptops, right? If you Google stopwatch, a little stopwatch widget will come up on your web browser. So just go into Google and type in stopwatch, and there'll be a timer there that you can use for that. Okay? All right, you're going to have more questions once you get into your groups, but I'm going to get you into your groups and get you some materials and have you get started. Your goal today is to get through all 3 labs, and then along with your groups, I'd like you to answer the questions in 1 through 12. If your group finishes that early, please get my attention. I'll get you guys your assignment, and you can spend the rest of your time working on that assignment. All right, questions for the greater good before we get started here? Okay. So I just wanted to quickly discuss what you guys came up with. One of these graphs is almost linear for some groups. It kind of depends. When we say linear in algebra and in geometry, we mean a straight line. Okay, actually in like formal math, there's no such thing as a curved line. Every line is straight. Curves are curves and lines are lines. Which of the 3 labs, A, B, or C, most look like a straight line when you graph those points? Which one most looked like a line? C, the sign on the dotted line one. So I agree that C for the most part. Now, it may not have been a perfectly straight line, but it was the closest to linear of the three. And some of you had some that looked exactly like a straight line. Part B says the town of Parsnipville, so this would go with the local crisis lab, has a flu vaccine available on day 7. There's 3,800 citizens. How many people are going to need the vaccine on that day? Now, who needs to take a vaccine? The sick people or the healthy people? What do you think? The healthy people need the vaccine, right? So can you look at your data for, what was signed on the dotted line? That was Lab C. Look at your data for Lab C. No, not Lab C. Thank you. For Lab B. And tell me, how many sick people were there on day 7? Was it more than 3,800? It was a lot more than 3,800, wasn't it? Like, so there's more sick people than there are people in the town. Now, is that number accurate? Can you have more sick people than there actually are? So would you agree that at some point everybody in the town is sick? How long does it take till everybody in the town is sick? How many days does it take for you to go over 3,800? 7 days, okay. So to answer this question, how many people are going to need that vaccine on day 7? How many healthy people are left? None. None, because everybody's sick already. All right, C is an interesting one. So on your hot tub, if you wanted the smallest perimeter, do you guys remember how to find the perimeter of a rectangle? You add up all 4 of the sides. Does anybody know which one would have the smallest perimeter? So for example, one of them was 1 times 36, 1 by 36. So you would have 2 sides that were 1 tile wide and 2 sides that were 36. So 1 plus 1 plus 36 plus 36 is 74, I believe. But there's definitely one that has the smallest perimeter. I'll let you think about that one if you're interested in it. I want to skip down to part D. This is an important question. Lab A was the hot tub again. Why is there no point on your graph where x equals 0 for the hot tub? Why is that not on there? And if you look at the table for the hot tub, why is there no row on our table that has 0? We had zeros for Lab B. We didn't have 0 on this table. Why does that not make sense for that situation? Why does 0 not make sense? Any ideas? What is the x representing in this table? It's actually labeled, which makes it a little bit easier. What is x representing? It's the width of the tub. Is it possible to make a hot tub that's 0 tiles wide? No. Okay. Folks, we got about 10 minutes left. I'm going to get you the assignment and ask you to get started on that.